Welcome to the cybersecurity session in the IDEA Virtual Academy. My name is Christian, I'm the head of the IDEA development team, and today I would like to go through some common threats in IT and show you how to stay safe, and at the end also have a quick look what we are actually doing to make sure your data is safe and secure on our servers. Let's start with the big truth. The only truly secure system is the one that is switched off and unplugged. That was quick. Thank you for listening and attending this session. Okay, jokes beside, there is something we can do about cybersecurity that still allows us to live in the 21st century. We need to pay attention to stay as safe as possible. To pay attention, we need to know for what we are looking for. My goal would be to show you the common threats in cybersecurity nowadays, ranging from social engineering attacks via phishing or using compromised or faked websites, public hotspots, to actually bad or outdated systems, maybe on your side, in your network, on your phone, on your laptop. There is a wide range of possibilities. We will go topic by topic and show you what could be a threat, how to identify it, what you can do to prevent it, and how to stay safe in your day-to-day business. Let's start with phishing. Phishing describes a social engineering attack that is actually not using a security hole or a bad configured system. It's trying to steal information or trick you into doing things by just pretending to be something or somebody that is very urgently and you need to pay attention to, or just trying to trick you into believing that it's a trusted organization. There's not really a software or something that can prevent you from getting this kind of things, but there are things that should help you to detect a phishing attack on you or maybe on your network or other users in the network. There are different types of phishing attacks. The most common one would be email phishing. I guess everybody got that email from that prince from around the world that has so much money and he really likes your name, so he wants to share it with you and need your bank details. Obviously, that's a very basic level of phishing, but there are more advanced techniques like spearfishing or even whaling, which describes an attack that is targeted on an individual person. For example, attackers try to collect information up front, like they use your Facebook page, your Twitter account, or other things that you make public available to target attacks that could fit to something that you have actually used, like maybe they know, okay, he's using Facebook, so let's try to fake a Facebook email and send something out. There are also attacks not via email, for example, using phone calls or SMS to trick you into opening a URL or just answering to, for example, confirm that this phone number exists, which then, of course, can be used for other types of attacks. One also very common attack, meanwhile, is angler phishing, which describes the way of sharing, for example, a link to a page that looks almost correct, but in the end, it's not correct. These links are often shared in social networks or via instant messages. For example, there's a very common thing that goes around. It's a web page, it looks like the WhatsApp website, but it's actually not, and it's trying to confirm your telephone number. So you have to type it in so you get an SMS to confirm that it's your number so you can use your WhatsApp web again. But that's not WhatsApp, and actually they're stealing your phone number. As we now know what kind of phishing attacks exist and what's the goal for a phishing attack, let's start building up some checklists so we can see if we have spotted one. Let's start with the emails first, as it's the most common attack. Is the email that you are looking at actually from the right organization? All parts of that email address have to match. So check the part in front and behind the ad. Make sure it is actually from the one that we would expect it to be. Does the email contain an attachment, something that you would not expect to be there? Does it create a sense of urgency that is not needed or doesn't fit into the context? Does it link to something that you're not aware of or something that looks simply wrong? Does it contain spelling or grammatical errors, or is the design of the email itself strange? If you answer to any of these questions above, yes or maybe, be careful. You might have spotted a phishing attack. Let's continue our checklist for the other types of phishing attacks you might encounter. Again, of course, the details matter. For a web page, have a look at the URL. It already provides a lot of information. Make sure that the URL is correct, that there's no little spelling trick inside, like shown here, putting an R next to an N, so it may look like an M. Make sure that the website is HTTPS, so it's using a secure connection and you do not transmit your data via clear text over the internet or the network. You can always click on the little log icon in your browser to get some additional information about the website. Also think about, how did you get to this page? Did you click on a link on a maybe already sketchy email or in a social media network or via an instant messenger message? Before you click, hover over the link to see the actual target, and if you're not sure, don't click. Is the website trying to immediately download you something or providing some files that you would not expect? Does it maybe contain spelling or grammatical errors, or is the design outdated, old, or simply doesn't match the actual company's design? The same for other sources for phishing. For example, if you get a link via SMS, it's not more secure as you would have got it via an email. Same for calls. It's the same issue, just in different shapes. Anything above answered with yes, or even a maybe? Be careful, you might have spotted a phishing attack. Besides the checklist, there are some other things you can do. For example, you can call the organization in question and confirm that they have contacted you. You can use online virus scanners like VirusTotal to check a file or a web page directly with 10, 20 different virus scanners to see an average result for something in question. And of course, the most simple thing, think twice before you act. It doesn't matter how urgent something might be. If you think before you act, you might save yourself a lot of time and money. Before we move on to our next topic, let me quickly summarize the key facts about phishing attacks. Phishing attacks do not use any security holes or trying to sneak into your system. They're actually trying to convince you to hand out information or take actions to provide information to somebody that should not have this information. The same could be said for our next topic. It just works a little bit different and involves more technical knowledge. Let's talk about public hotspots. They're quite normal nowadays. You will find them at airports, restaurants, hotels, public places, in a harbor. You are most probably very used to use them, but there are some downsides that come with this kind of networks. You are sharing your information over a network. You actually don't know who else is in this network or who maybe created this network. Like mentioned, there are some technical skills involved to set up something to create a network and get into your or at your data, but it's still also kind of a part of social engineering. In the next slides, we will have a look at what are the possible problems, how to recognize and maybe prevent them, and see what you can do to make sure you stay secure also on the go. Let's quickly discuss where are actually the dangerous parts of a public network or what might be problematic about them. First of all, you don't even have to actively use it. You just need to be connected. You're part of that network. So an attacker could scan the network for clients and check, for example, if they have file sharing active without an account or without a login. So he could download your files, upload files to your computer. He could also check for other kind of software running on your computer that has maybe known security problems. So he could, in the worst case, execute commands or code via remote. So he doesn't have to go to your computer to do it. He can just do it from wherever he is. Beside that, he could read the data you've sent over the network, because on a Wi-Fi, all the data that gets sent out to the clients is available to every client. Normally, they would be discarded because they are not for your computer, so your computer will ignore them. But there's software that is able to read all the packages flying around and then, of course, makes use of the information inside. So if you communicate over a non-encrypted channel, your data can be read by everybody that is part of that network. Of course, you can also simply directly spin up a completely fake hotspot. It's easy to spin up a hotspot. Just think about how you can do that with your phone. It's a few clicks and you got it. If you spin up a hotspot with, for example, a laptop or some other hardware, you have full access over it. So you can see the traffic that runs through this point. You can, of course, change requests. So you can forward users to fake pages. You can use other social engineering tactics to get the data of your users or trick them into providing passwords, phone numbers, email addresses, or whatsoever. Or what is at the bottom here, man in the middle attack. It simply means I sit between you and your actual server you want to talk through and read all the data you send, maybe even manipulate the answers you get from the server to trick you into believing that all is okay, but actually your account is already in danger. Unfortunately, it's not so easy to avoid fake hotspots. So detecting a fake hotspot is complicated. The golden rule here has to be assume all public networks are not secure. So you should not use them. Let's say it like this. If you can avoid it, I would recommend to not use them. But there are some ways how you can make sure that you get the benefits of a Wi-Fi network with the maximum security. First of all, like for most of the things in IT, make sure your operating system, your device is updated regular. Don't miss security updates. Make sure that file sharing is turned off or protected by logins. Do not share your drive, a folder without a login. Ensure that you have an antivirus or firewall software active and updated, because an outdated antivirus software doesn't help you at all. Make sure that you turn off the auto connect to open networks on your devices. Otherwise, you might even not notice that your device connected to a free hotspot. So turn this off. And very important, if you can, use a VPN connection, which is a private tunnel through the network to your trusted network, and it encrypts your communication as well. Some public hotspots do have a sign-up page. That means you can connect to the network, but to actually use it, you need to sign up with a password that you maybe find somewhere on a note in your room or on the menu card in a restaurant, or you have to provide them an email address or something else. That unfortunately doesn't make it more secure. For example, if I spin up a fake hotspot and I create my nice login page and I'm asking for your phone number, your email address or something, and you type it in, I got your phone number and your email address. Thanks for sharing that information. So keep in mind, if the hotspot require you to log in with something via email, social account, think twice before you share this information. And on a side note, most of the time you can type in anything that looks like a phone number or email address and it will run through. So don't share your valuable information with any wild network out there that you might want to use. So far we talked about social engineering, how to detect it, what kind of types are there, how to avoid it, and how to deal with it on a day-to-day business. But there's actually something that's directly in our hands, and that's our IT systems. So let's do a little 101 on IT systems. On the side note, if your server room looks like this in the picture, I have bad news for you. Because key to any good IT system is separation and isolation. What you see here on the screen, do one thing and do it well, is actually one of the design concepts of the Linux operating system, but it fits very well into modern IT landscape. A server should be there for one good reason, and it should do this and nothing else. So keep the things isolated and separated. Don't put everything onto one machine. Same for backups. Well-planned backups can save you a fortune. I always tend to say no backup, no mercy, because that's actually true. You have to make backups of your systems. The backups have to be separated and isolated from the actual system. And the backups have to be, of course, checked. Keep your software updated. It's simple, but it's very, very important. Make sure that you have auto updates activated and frequently check if these updates are really installed or if there's any problems with this kind of services. And please do not run systems that are no longer supported. Don't keep that risk in your network. Speaking about networks, what can we do to make sure that our networks are safe and secure? Let's start with Wi-Fi networks. Obviously, Wi-Fi networks are more in danger to have a security problem because you don't need to plug in a cable to something. You can just sit somewhere and try to use it. So whenever possible, try to use WPA2 enterprise encryption. The big difference between the, let's say, normal encryption is that it requires every user to have a username and a password. So that enables you to manage the users and provide a unique password to each of them. No longer you can just log in by one passphrase. You need to have a combination out of username and password. If somebody leaves you, you can remove his account and automatically remove the access to the network. If your network equipment doesn't support this kind of encryption, then of course you still have to use WPA2, then in PSK mode, which stands for pre-shared key. The important point here is to choose the right encryption. It's either AES or CCM. Both stands for the same kind of encryption. Make sure to use it. Beside the encryption, a strong password is very important. Please use a minimum of 15 characters to slow down or prevent any kind of brute force attack that might want to crack your password. Inside your networks, you do have the option to use VLANs, which stands for Virtual Local Area Network. It's a virtual layer inside your physical network that can separate the network to different subsections. You could separate decks, departments, or business relevant or private networks. VLAN also allows you to separate or to block certain kind of services. So, for example, you could stop any kind of file sharing, or you could stop the usage of video streaming services, or anything else that should not be part of your network. VLAN also allows you to use a tagged mode. That means you can make sure that a known device is always tagged with a special tag. So it doesn't matter where this device is plugged in, it's always moved into the right network. This tag can be either by the machine or by the user. It's a little bit comparable to the enterprise mode of encryption. It just adds another layer to manage and to separate different kind of users and permission levels. Let's speak about mobile devices. So everything which is easy to move around, let it be a laptop, a mobile phone, a tablet. It's important that you encrypt the data on these devices and that they are protected by a PIN or password. And of course, make use of this protection. So when you leave them, Lock it so that nobody can easily access the data. Do not store your passwords in a password.txt directly on your desktop or on a note somewhere at the bottom of the device. Please keep the software updated so you don't expose these devices to known security problems. Make sure that only people that actually have to use these devices are able to log in. Do not plug in unknown USB devices. Make sure you have antivirus and firewall software installed and updated. We talked about our own hardware and networks, but what about external services that we use every day, like mail clients, social media, or any kind of sharing services? There are some good points we should consider and keep in our mind. First of all, the passwords. Passwords have to be unique, so you should not use the same password twice. Make sure to use a strong password. So you could use a password sentence to keep it in mind. The brown fox jumps over two fence, and then just take the starting letter of each word. Do not use common words in your passwords like secure password. They can be easily cracked with a dictionary attack. Make sure that you use HTTPS so your communication to that website or to that service is encrypted. And if available, I highly recommend you to use two-factor authentication. That adds another layer on security and might save you one day if there has been a problem, maybe even with that service. Speaking about problems with external services, there is a web page online which is called Have I Been Pawned? This allows you to search with your email address in millions of data leaks that were published or were discovered and see if any of your details are made available to the public in the end. Checking passwords can be done with useapassphrase.com. It allows you to check the strengths of a password, and it also gives you some ideas on how to generate good passwords. We talked about a lot of ways and best practice to make sure that on a day-to-day business we can use our IT systems in a safe and secure way. Now let's have a look what we actually do to make sure that your data that is maybe running on our service is safe and how we do handle feature requests or bug fixes. So I would quickly like to show you how our product development team works. Let's recall what I mentioned before. So what you see here right now is what we do for our online service. We do backups, we do daily backups. We move backups to a different location, so they are not on the same machine that generated them. They're actually not even in the same building. We do use encryption for all the communication and we make sure it's up to date. We renew our certificates every 90 days. We separate our services by their job. So a website is running on one machine and the database server is running on a different machine. And of course, the database can only be reached from the website server and not from the outside. We make sure that not everybody can access our service. We have a firefighting system and an emergency power supply. We check our system regularly. Actually, we get daily reports and do a full manual weekly check and have a scheduled maintenance plan for the whole system. This includes updates for the operating system, replacement of hardware, checking of network components, and a general health check of the whole hosting environment. So you can see there's quite a lot of work you need to put in to have a safe and secure and of course reliable system running, and especially if you expose this system to the internet. You can have the best system in the world, but if the software you're running on that kind of system is not maintained well, it doesn't really help you. So let's have a look how we handle software changes. What you can see here is a summary of our development workflow. So assuming you work in the PD team for IDEA. You get a task out of our task system. You work on it. You complete it. So that means you did what the task asked you to do, you tested it on your own. So you transmit it and you use our version control system. So every change you do is checked and documented. Now our Q&A team gets a notification and sees, okay, there's a change for this ticket, this is what he did, and he can test this now. The test passes, and the tester documented this in our ticketing system as well. Tomorrow morning, when you come to the office, our automatic build and testing system will have built your changes into IDEA, will run our test cases, and will present you a result that sees how your changes behave in the whole picture of IDEA. Every developer, or actually everybody in IDEA, can access these test cases on a daily basis. If we are close to a release, we will generate an update or installation package out of all the changes that have happened before. This generation of the update and installation package is again done by our build system. So at the end, we get a file that can be used to update IDEA. We push this file to our server and start the rollout. Our server will check to make sure, is there a backup of the page before I update it? Do I back up the database? And then copy the update in, ensure that that's worked, starts up the page, and then, if needed, does some steps at the end to make sure that everything is back and ready to be used by the customer. Having this kind of process makes sure that we don't miss any changes and that we test them as much as we can. Of course, that doesn't prevent failures. There's always the possibility that something sneaks through, but it provides us the capability to react quickly and know that if we change something, we didn't break something old. As you can see, there are quite a few steps included also on the software side to make sure we get a safe and secure system. And with this little tour in the idea side of IT systems, I would like to thank you all for listening to that presentation, and I hope you got something out of it. And now we would have time for any questions. Feel free to ask, and we will try to make our best to answer it.